With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
In this question, the displacement time graph of a particle executing simple harmonic motion is given in the figure. So we have to find out which of the following are true for this motion. So here's a displacement time graph of a particle which is executing simple harmonic motion. This graph is the same as we get in a particle here. For example, here's our spring attached to a mass m, and it is executing an S.H.M here. So we can write the displacement as x is equal to a cos omega t. As here we can see that the phase angle is 0 and the time period here is t,
and the graph resembles to a cosine curve.
Or we can consider here that there is a string of length L taught to a particle of mass m, and it is oscillating to and fro. So here let's just assume that our spring motion is into consideration. So we have to find out that the force is 0 at t is equal to 3t by 4. At t is equal to 3t by 4, the displacement is 0. So let's just see what this graph really tells us. So this is, let's just say this is the mean position of the particle, and at x is equal to 0, let's just say the time here is t by 4, and let's just say this is the extreme position of this spring of this mass here, and this is the extreme position, and x is equal to 0 here is the mean position, or we can say equilibrium position. So the force is 0 at t is equal to 3t by 4 tells us that it is in equilibrium position as the displacement here is 0. We know that the force here is 0, so this statement is correct. We know that in the equilibrium position the force that is applied on the body is 0. Now let's just consider this second statement. The acceleration is maximum at t is equal to t. The acceleration at t is equal to t, here the displacement is maximum. So the particle of mass m here is at the extreme position. We know that here the acceleration is maximum, or we can just take the magnitude of acceleration. We know that this is omega square x. So when will this acceleration be maximum? When x is maximum. Alright, so the maximum acceleration is when this x is maximum, and x is maximum at extreme position. So we have just proved that the acceleration is maximum at t is equal to t. This is the amplitude. So we can write here omega square a, and this is the maximum acceleration. That's why the statement B is correct. Now we have to find out if the speed is maximum at t is equal to t by 4. So at t is equal to t by 4, we see that the particle here is at the equilibrium position. So at equilibrium position, at this point here, the speed is maximum. We know that at the equilibrium position the speed is maximum, and at extreme position the velocity is 0. So this statement is also correct. Or here we can also see that the magnitude of velocity is given by omega under root a square minus x square. So at equilibrium position x is equal to 0. So this also becomes omega a, which is the maximum value of velocity at x is equal to 0. That means at equilibrium position. So the third statement is also correct. Now we have to find out the potential energy is equal to kinetic energy of the oscillation at t is equal to t by 2. So this is t by 2. We have to find out if the potential energy is equal to the kinetic energy here. So here we can see that the particle is at the extreme position because the displacement here is maximum. So at extreme position, the potential energy is maximum, but the kinetic energy is 0. Also, we know that at the equilibrium position here, the kinetic energy is maximum, but the potential energy is 0. And the extreme position, the kinetic energy is 0, but the potential energy is maximum. So here in between, there must lie a point. In here, there must lie a point where kinetic energy and potential energy are equal. So let's just point it out where it is. So the potential energy is equal to kinetic energy. Potential energy expression is half kx square. And kinetic energy is half k a square minus x square. Therefore, we can write x square is equal to a square minus x square, or 2x square is equal to, this is 2x square is equal to a square. Therefore, x is equal to plus minus a by root 2. So at x is equal to plus minus a by root 2. So it is here, here, and here. At these points, the potential energy and kinetic energy are equal, not at t by 2. So the statement D here is wrong. So let's just match out the options here. So here we know that A, B, C and correct. Therefore, option 4 here is correct.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.